Hello guys, welcome again to this video. So in this video we are going to start about continuous random distributions and continuous random variables. So this kind of distributions are the ones where we do have the random variable taking on values in a continuous interval. It may be a closed interval, it may be an open interval, and it's unlike those of the discrete distributions where we have like point values or already defined values like the Bernoulli distribution or the binomial distribution. And since it is a discrete distribution, what we do use is integration instead of summation to find probabilities and related stuff. So let us have an overview of what to do. Continuous random variables. So then thing is, if x is an continuous random variable, then it will take on some values from a set D. So x will set some values from a domain D, which is a subset of the real numbers R, and what we can define is we can associate a PDF with it, and I will define the PDF below. So the PDF that we are going to associate will look like f subscript capital of X and f of X basically, and this PDF would be something which will satisfy the properties that it will be greater than or equal to 0, and that the integral over all the values of the function, that is the integral over the whole real line, would give you always a 1, that is the total probability is 1. So these two are the conditions that need to be satisfied in order for fx to be a PDF of a continuous random variable x. Now similarly, I'll give some examples very soon. So but before that we need to understand a few things, that f is a function which takes in values from the domain D, because it takes in all the values that the random variable x takes, and it goes, and the value it gives you is basically given by 0, 1. So like that is the range of the variable, because obviously we know that the probabilities lie between 0 and 1. So we will have an example here. So we need to check if f of x equals to 3x square, where x is in the open interval 0 to 1, is a PDF or not. Well, then there are two conditions for which PDF needs to be satisfied, which is as follows: the condition of non-negativity and the condition that the total probability is 1, right? So how to formally write it? So what you will do is as follows: if such a question comes and you need to write it subjectively, well, since x is belonging to 0 comma 1, this means that and therefore 3x square is also greater than 0, and therefore f of x is also greater than 0. So obviously the condition for non-negativity is satisfied. Now the harder part, which is to find if the total probability is 1 or not. So the total probability is given by so anyways we need to prove that it is equals to 1. Now when we integrate over the whole real line, we understand that this function is only defined for x belongs to 0 and 1, 0 to 1, and for other values or other intervals or the whole real line it is 0. So except for the interval 0 to 1, it is 0 everywhere else, right? So we learnt in integration that we can divide minus infinity to plus infinity, which is basically the whole real line, and we can divide an integration into subregions, right? So what we can do is we can write minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx. And since the parts, the first part and the third integral, both of them are 0, because f of x is identically 0 itself, so there is no point in integrating 0 over any interval because it is always 0. We can write this as so like this would be the integrals, right? Now this would be equal to 0 to 1 3x squared dx, and as we have learnt in integration, the constant 3 comes out and it becomes 0 to 1 x squared dx. The antiderivative of x square is simply x cubed by 3, that is and this would give you 3 into 1 by 3 minus 0 by evaluating the antiderivative at the limits, and this would give you 3 into 1 by 3, which is basically 1. Then therefore f of x is actually a PDF. So it is a PDF, right? So this is one of the ways we can show any function, if it is a PDF or not, or if it has the properties to act as a PDF for a random variable x or not, right? So this is how continuous random variables or continuous distributions work. They are similar to discrete distributions, except for the fact that we have to integrate. Also, one important fact is probabilities of singletons to explain that. For example, in the previous example, if we were to find out the probability of x equals to 0.5, it would have been equal to the probability of x equals to 0.75 as well, because all of them would have been equal to 0. So point probabilities are always 0 in a continuous distribution. So you can see the major difference between the continuous distribution and the discrete distribution here, that they actually differ in the fact that point probabilities are not usually 0 in discrete distributions, but here they are 0. So anyways, that would be it for this video. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes, where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes, we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also, you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel. Thank you again.